Okay. So we're going to do half of 6-2 today. We're going to do half the lesson today, half tomorrow, and then Friday is going to be another work day for you guys. You can work on either your 6-2 or your 6-2 homework. I'll get you that 6-2 homework at the end of the period. So today and tomorrow we're going to talk about sum and difference identities, which if you look at your identity sheet, if you look at your identity sheet, these are going to be the 6 that are in the top right corner. So these are the ones with the U's and V's on your identity sheet that you're going to be doing in this section. So again, we're just going to be adding those few in. We'll get to the other ones later. So all you need for the 6-2 homework is your fundamental identities that we've been practicing with, plus those extra 6 sum and difference identities. All right, so we're going to start with the sum and difference identities for cosine. How these identities work is, let's say I asked you to find the exact value of cosine 15 degrees. 15 degrees is not on your unit circle. We've got 30, we've got 45, we've got 60, we've got things, you know, going all the way up or down to whatever, but 15 is always something that we're going to jump over if we go around our unit circle. But 15 is 2 of the values on our unit circle that are subtracted from one another. 45 minus 30, for example. And there's a lot of different ways to do it. You could do like 150 minus 135. That would also give you 15. If you can add or subtract 2 values on your unit circle to get a new angle, you can use a sum and difference identity to evaluate that angle. Okay, and the U and the V in these formulas represent the 2 angles on your unit circle that you were adding and subtracting. If you do not use angles on your unit circle, you can't do anything with it because you don't know what the cosine or the sine of those values are. So like if I want cosine of 15 and I add 5 and 10, that'll give me 15, but I don't know what 5 and 10 degrees evaluate to on my unit circle, so that doesn't help me at all. So you have to make sure U and V are always unit circle values. All right, so we're going to do this first one. It says find the exact value of cosine 7 pi over 12, again, not a unit circle value, and they're telling us that 7 pi over 12 is pi over 3 plus pi over 4. So sometimes they'll tell you what angles you want to use, add or subtract, and sometimes you'll have to figure that on your own. So we'll do that in a little bit. All right, so that pi over 3 and pi over 4 are going to be the U and the V in the formula. So cosine 7 pi over 12 is equal to cosine pi over 3 plus pi over 4. Okay, and again, that's my U and my V. Okay. All right, so because it's addition, I'm using the identity on the top. Everywhere I see a U, I'm going to plug in pi over 3. Everywhere I see a V, I'm going to plug in pi over 4. So that would look like cosine U, pi over 3, cosine V, pi over 4, minus sine U, which is pi over 3, sine V, which is pi over 4. Okay. All 4 of those things in the formula now are things that you can find with your unit circle. So again, we're back to our unit circle now. There's going to be more numbers in this section, more things that you calculate rather than just all proofs like we saw in the last section. All right, so to your unit circle, what is the cosine of pi over 3? Long pause. Come on, guys. Cosine of pi over 3. It should be quick. 1/2. That's correct. Pi over 4. Cosine? Guys, you cannot forget your unit circle. Rad 2 over 2. Minus the sine of pi over 3. Good. Rad 3 over 2. And the sine of pi over 4. Again, rad 2 over 2. Good. All right. And I can put that first one in parentheses too. All right. Multiply them together, numerators and denominators. So the first fraction, I'm going to get rad 2 over 4. In my second fraction, I'm going to get rad 6 over 4. And then they have a common denominator, so I can put them together. Denominator is a 4. My numerator, you cannot add or subtract radicals unless they are the same radical, which they are not. Rad 6 doesn't break down. This is your final answer. All right, can you guys grab your graphing calculators real quick? I'm going to show you how you can check this. Put your graphing calculator in Radian mode if it's not in Radian mode already. Okay. You could even do this on a basic calculator. It's a little easier than the graphing calculator. Okay, so Radian mode. And I just want you to type in the original problem, cosine 7 pi over 12, and hit enter. So get that decimal. Okay? And we need to be in radian mode, so we're typing a radian in. You guys know if it was degree mode, you have to be in, or a degree, you have to be in degree mode. Okay, so get the decimal for your original problem, and now type your answer in using the alpha y equals button. So type this guy in, rad 2 minus rad 6 over 4. If it's right, you should get the same decimal twice. Now that decimal is never an answer you should give me because it's not exact, but you can compare the two and see if they're evaluating to the same thing, which they should. Okay. Work okay? Good. Okay, so this could be something you could do on your homework. If you're at home and you're not sure if you get the answer right or not, you could quickly, with your calculator, type it in and make sure your answer matches whatever the decimal approximation for the original problem is. Good? Okay. All right. You guys try this one. You can work together on it. So you're going to find the exact value of cosine 15, and you're going to use the fact that 15 degrees is 45 minus 30. So 45 and 30 are going to be your u and v. This time you're subtracting, so you're using the identity on the bottom, cosine u minus v. All right, I'll give you a minute. Go ahead and try it, and check it with your calculator when you're done. Okay, let's see how you did. Rad 6 plus rad 2 over 4 should be your correct answer. Or you can switch those if you have rad 2 plus rad 6. We know that means the same thing. Any questions on that? Okay, so those are the cosine identities. Next slide is our sine identities, really similar. So the cosine identities, you'll notice the functions themselves have cosine next to a cosine and sine next to a sine. The sine identities are flipped. You have a sine and a cosine and another sine and a cosine. Now, if I'm memorizing these, I remember that sines have the same sign. So the one that's a plus has addition in the identity. The one that's a minus has subtraction in the identity. The cosines are opposite if you look at those ones. The cosine one that was a sum had a minus in the formula and vice versa. But they work the same way. We're just going to find those two angles on our unit circle to add or subtract to the given angle to be able to evaluate it. So here we want the exact value of 5 pi over 12, and we're not given two angles that we want to add or subtract together, so we need to figure those out. I will say this is definitely one of the times where degrees are probably going to be easier just to find what adds or subtracts because you don't have to worry about like common denominators and things from your unit circle. So the first thing that I would do on this is I would just convert this real quick to a degree. Do you remember what we multiply by to convert? 180 over pi, yep, okay. So pi's are going to cancel, and then you have a calculator. You can just multiply 5 times 180 on top, divide by 12. I'm going to get 75 degrees, okay? So we've got sine of 75 degrees. Okay, so now we want to find two angles that add or subtract to 75, and they can be anywhere on your unit circle. Let's find two that subtract. The adding's too easy. What are two angles on your unit circle that subtract to get 75 degrees? Go ahead.
35 and 60.
That would work. Okay, there is not one correct set of angles that you use here, but there are a lot of different ways that are going to get you the same answer. So if you chose addition and you did 30 and 45, you would see you get the same answer at the end. Okay, so again, remember the first one is our u, the second one is our v. That order is important because subtraction, we know order matters. Okay, because it's subtraction, I'm using the bottom identity. Sine 135, cosine 60, minus cosine 135, sine 60. All right, and now we evaluate with our unit circle. So what is the sine, the y coordinate at 135? $135. That's our 45-degree reference angle, right? 135 is in quadrant 2. What's that point, that y coordinate? Rad? 2/2. Cosine is 60. X coordinate at 60 degrees. Please tell me we have not forgotten our unit circle. I'm thinking unit circle quiz tomorrow right now in my brain if we have forgotten this. You guys are stressing me out right now. Cosine of 60, guys. Come on.
1/2.
Yeah, 1/2. Come on, we know this. Tell me that you know this so I don't have to quiz you on it again. Cosine of 135. Close. Negative rad 2/2. Yep. And then sine of 60. Good. Okay. We know this. All right. First fraction is going to be a rad 2 on top. The second fraction, you've got a minus negative there. So it's going to be a plus rad 6 on top. And they're both over 4. So eventually you can put them together. You can do all that at once if you want, or you can do that in 2 separate steps. Make sense? Yeah.
You might have said I shouldn't care. Is there any reason why we didn't do plus 45 degrees plus 30 degrees?
No, there isn't, because I just wanted to do a subtraction one, and I wanted you guys to see something that was in quadrant 2. But you could absolutely do that and get the exact same answer. If it doesn't give you 2 angles to use, honestly, it's probably going to be easier to pick something in quadrant 1 anyway, because then you don't have to worry about negative signs. You're less likely to make a mistake with that. But there are lots of different ways to get the same answer with these. Okay. Good? Okay. So I want you to go to, we're going to skip the next problem. I want you to go to this slide, and we're going to change it a little bit. We're going to change it to cosecant still, but this time 5 pi over 12. Okay. All right, so I'm choosing 5 pi over 12 because we just did a problem with 5 pi over 12. The last problem we did was sine of 5 pi over 12. And we found that the sine of 5 pi over 12 was, which one was first? The rad 2, I think. Rad 2 plus rad 6 over 4. Okay. You do not have identities for sum and difference for secant, cosecant, cotangent. So if you have a problem like this, you can't use the sum and difference identities yet. You have to first use your sine, cosine, and tangent sum and difference identities. And then we're going to take these answers, whatever you get, and we're going to flip them. So it's kind of a combination of sum and difference and our reciprocal identities from before. So sum and difference gives us the sine, it's reciprocal. And then if I want the cosecant, all you do is you have an extra step at the end. You're going to flip that answer, or reciprocal identity. So it's going to be 4 over rad 2 plus rad 6. Now, the reason I want to go through this is because that now needs rationalized after you flip this. And because there's 2 radicals in the bottom, it's not as easy as the rationalizing we've seen before where you just multiply by 1 radical over itself. If you have 2 radicals added or subtracted, you need to multiply by a conjugate on the top and the bottom. And remember, conjugate means same terms but different sign between them. So instead of rad 2 plus rad 6, I'm going to multiply by rad 2 minus rad 6 on the top and the bottom. Okay. Now on top, you are just distributing that 4 through. So that gives you 4 rad 2 minus 4 rad 6. On the bottom, technically you're foiling, but they're conjugates. And what happens when you FOIL out conjugates? The outside and inside cancel. So you really only need to do first and last. First terms are rad 2 and rad 2. What's rad 2 times rad 2? 2. And my last terms are a positive rad 6 and a negative rad 6. Well, what's rad 6 times rad 6? 6, and one's a positive and one's a negative, so it's negative 6. All right, so now if I simplify that, I have 4 rad 2 minus 4 rad 6 all over negative 4. And then this fraction reduces. Every fraction, or every term in this fraction is divisible by what? 4. And even better, you can divide by negative 4 and get rid of that denominator completely. So if I do 4 rad 2 divided by negative 4, I get negative rad 2. If I do negative 4 rad 6 divided by negative 4, I just get a positive rad 6. And then your denominator divided by negative 4 is just a positive 1. And then that's your final answer. And then this you can check also in your calculator if you want to. Of course, you can type the answer in. If you wanted to check the original problem, you would just do 1 over the sine of 5 pi over 12. That's what you would type in your calculator to get the cosecant. And then you can compare the two if you want. Okay. You're going to notice when you do these problems, are you guys seeing like we get the same numbers over and over again? With the 4s and the 2s and the 6s, and the only thing that's changing are these pluses and minuses. That's because we're using unit circle values, and there's only so many ways that we can like add and subtract and multiply those together. So even if it seems wrong that you keep getting the same answer over and over again, or the same type of numbers over and over again, that's probably a good sign when you do these. Okay? Questions on that? No? Okay, cool. All right, so we're just going to do a couple more things with just the sine and cosine identities. Tomorrow's lesson we'll add in the tangent identities. We're going to prove a couple identities with these. So I actually think the proofs now are going to start to get easier for you because it will become obvious what group of identities you're going to need to use. If you see a parentheses with a plus or a minus in it, you are automatically using sum or difference identities. This sine pi plus x, that's a u and a v that you're given. The only option you have to start this identity is to use that formula, the sine u plus v identity. The biggest mistake that you can make that often people try to do is they try to distribute the sine in, but the sine is not, there's not an angle after it. The angle is what you're trying to distribute it into, if that makes sense. So we cannot distribute over a parentheses unless there's like an x next to that sign. Then we would be allowed to do that. All right, so the sine u plus v identity. So I'm expanding that left side, okay? So that's going to be sine u, so pi, cosine v, so my x. Sine has the same sign, so plus cosine u, so cosine pi, sine x. Okay. Now, sine pi and cosine pi are things that you can find on your unit circle. What is the cosine of pi? Or sine, let's do sine first. What's the sine of pi? Sine pi is 0. Cosine x. What's the cosine of pi? Close. -1 times the sine of x. Well, what happens when you multiply something times 0? It's gone. And -1 times sine gives me negative sine. And that's what we had on the other side. Negative sine. And that is the end of my proof. Okay. Okay. Next one. I've got a cosine x plus y on top. You don't have a choice. That's a u and a v. The first thing you are doing is expanding that numerator using your sum and difference identity for cosine. Okay? So, cosine u, which is our x. Cosine v, which is our y. Minus sine u, sine v. So it's going to be sine x, sine y. Over sine x, sine y. And I'm just going to leave that right side alone again right now. Although it is tempting, are you allowed to cancel that sine x, sine y? No, you are not. Okay, but if you did, that would be really great. So what I'm going to do is I need a cotangent. Cotangent is what for your quotient identities? What is cotangent equal to? cosine over sine. If I can get this sine x sine y just under this first part of the fraction, I have my cotangents. I have a cosine over sine for x, which would be a cotangent x, and I would have a cosine over sine for y, which would be a cotangent y. So what I'm going to do is I'm going to do the opposite of when we add things together with common denominators. I'm going to split this fraction into two fractions with the same denominator because I want to separate those two pieces in the numerator from each other. So I'm going to have cosine x cosine y over sine x sine y minus sine x sine y over sine x sine y. Okay, and you can see this is exactly the opposite of what we usually do. Usually we start with this, we add them together with a common denominator, denominator stays the same, and we put our numerators together. All I did was do that step backwards. But now, because I've separated these, it allows me to cancel the things I wanted to cancel. Even though I couldn't factor, I can cancel now. Sine x sine y over sine x sine y is going to simplify to what? It's just going to simplify to a 1. And then, like I said, we have cosine x over sine x, which is those are multiplied, so that's why I'm allowed to do this, cotangent x. And then cosine y over sine y is a cotangent y. And you can see that's what you have on the other side, so that's the end of your proof. Okay, good there? Question? No? Okay, cool. All right, let's try this one. Sine 43 cosine 13 minus cosine 43 sine 13. It says find the exact value without a calculator. This would be a no calculator problem. This looks really complicated with like the 43s and the 13s. But I will tell you, it's not too bad if you just look at kind of the general shape or setup of this problem. So ignore the angles themselves. Look at what we've got. We have a sine cosine minus a cosine sine. Can you find that formula on your sheet, the one that has that setup, sine cosine minus cosine sine? Which one is that? It is sine u minus v. All you're seeing here is they already filled in the right side of the formula, so we're going to use the left side. What's u that they used? 43. And what's the v that they used? 13. And we can simplify that. What's 43 minus 13? Gives me 30. And then that is something we can do without a calculator. Sine of 30, unit circle. What is it? 1/2. Okay, so if you see these really complicated setups with like weird angles, this is probably what they're doing. They filled in half of the formula for you already, really the difficult side, and you're going to use the easier side. Okay? All right. I think this is going to be the last one that we're going to do today, then we'll stop. All right, so this one says, let sine of u equal -3/5. Cosine of v equal 12/13. U is between pi and 3 pi over 2. V is between 3 pi over 2 and 2 pi, and our instructions are to find the exact value of sine u plus v. Okay, we did problems that had information like this in chapter 5. If you are told u is between pi and 3 pi over 2, what do you know about it? It's in quadrant 3. And if we're told v is between 3 pi over 2 and 2 pi, what quadrant is it in? Quadrant 4. So the first thing that I'm going to do, if I know what quadrant something is in, I'm going to draw a picture. And there's going to be two different triangles here, one for u and one for v. Okay, so in quadrant 3, here's my reference triangle. Remember, right angle on the x-axis, theta near the origin. And actually, it's not a theta here, it's a U. Let me do better. There we go. All right, so what do I know about U? I know the sine of U is negative 3/5. So what can I label in that triangle? What two sides? Opposite and hypotenuse. And remember, the hypotenuse should always be positive. Can you tell me what the missing side of this triangle is going to be? It's going to be 4, 3, 4, 5 triangle, and it's negative because it's in quadrant 3. That's why it's important to draw your triangles in the right quadrant so you know where your plus and minus signs are. All right, that's all we need for U. Let's do the same thing for V. All right, what do I know about V? I know its cosine is 12/13. So what two sides do I label? What two sides are cosine? Adjacent over hypotenuse. This is another Pythagorean triple that you should recognize. If not, you could use your Pythagorean theorem. What's the missing side? 5, and it's negative, again, because it's in quadrant 4. So know those one, it's going to help you. 3, 4, 5, 5, 12, 13. We're going to see those a lot. Okay, so that's everything we need. Once you have the triangle, you can do your identity. So the identity that we are evaluating is sine U plus V, which is sine U cosine V plus cosine U sine V. Now you're going to find all 4 of those pieces in your picture. Okay. Sine of U, and actually we don't need that one from our picture because we were given it, is negative 3/5. And cosine of V was another given, 12/13. Okay, and we are finding the sine and the cosine, so sine and cosine disappear when I do this. What is the cosine of U? So we're going to look at triangle U that we drew and find the cosine of it. What is that? What is the cosine of triangle U, of angle U? It's adjacent over hypotenuse, negative 4/5. And the sine of V. Okay, so look at triangle V. Sine is opposite over hypotenuse, negative 5/13. Multiply them together. The first fraction will give me negative 36/65. My second fraction will give me 20/65. And when I add them together, my final answer will be negative 16/65. If you give a decimal answer for anything in this section, it is wrong. There should be no decimals. Things are coming from our unit circle or from a triangle. If you're missing information, you need to draw the triangle. All right, so tomorrow then we'll do one more practice problem, kind of like this with the triangles, and then we'll also add in the 2 tangent identities, and that'll wrap up this section for us. Okay? Any questions? All right, when you're doing your homework, you want to keep this identity sheet out. It might even be helpful now to keep your unit circle out too, because all of that stuff from chapter 5 is coming back in again. All right, let me get you your homework packet. Remember, 6-1 and 6-2 homework packet, both of them are due next Wednesday at the beginning of the period. So hopefully you got a good chunk of 6-1 done yesterday. You'll have a work day on Friday as well.